Okay, let's take a look at this 2014 question. I wouldn't think it's very challenging, but what they're testing is they're testing a mix of many concepts. So we have angle properties here, similarity, and then most importantly, look at the last one. That's the similarity of two-dimensional figures. So you're going to compare triangles and different shapes, right? Okay, so we're going to just scan through the first few real quick because what we have here is that we are given that this is a parallelogram. So even if they never label for you, please label yourself because it allows you to find a lot of equal angles. Okay, so the first part, what they want is that they want ABF. So this is how many marks? Let me see. I believe this is about 1 mark only. So when I have my ABF, right, this is my ABF. So what we see from here is that we're going to try to see ABF is equals to what angle from here. So we can see that if we see an alternate this way, ABF is clearly equals to this one here. Okay, so what we have here is that what you can always do, reasons are very important. So we're going to write down angle oh my God, what am I writing? BFC first, which is 180 minus 97, which gives me 83. This one is adjacent angles on a straight line. All right, please remember to write the word adjacent. Don't just put angles on a straight line. Not good enough. Okay, then after that, angle ABF, which is what they want me to find, right, will just be 83. That's because of alternate angles. So your reasons, please state clearly, even when they never ask you to. Okay? Okay. So then the next thing that we're going to look at is how do you show that triangles are similar? So the typical way is must know. Fastest way is always by AA. Second way is you got to show me that all three pairs of corresponding length ratio, right, equals to the same thing. All right. The third one, which is the most irritating one, if the first and second doesn't work, you just show me one angle that is equal and find me two pairs of corresponding length ratio. Okay, that one not so common in O levels for now, but when you're looking at prelim questions, right, or even your Sec 2 EOY, right, when you're just introduced to similarity, right, this one is very common here. Okay, so the next one is how do you show me that the triangles are similar? I want you to always be very sensitive to this. When they talk about similar triangles, right, the most common type of triangles will always look this way. Okay, wait, these are not very nicely drawn. Okay, they always look this way. So what we have here is that parallel. So you can spot your parallel lines. So this triangle similar to this big triangle. This top triangle similar to this one. So when you see BCF and EDF, look, it looks just like this, right? So what we have here, we're going to start with angle BFC. When you name right 1, 2, 3, this side also angle EFD. I always tell my students, the moment they give you this, right, please don't torture yourself and look at the corresponding length, corresponding vertices in the diagram. Just look at the way they write it out. It will always be in order already. So this one is my vertically opposite angle. Okay, then what I have next is I have my anyone lah, BCF. So BCF will be EDF. This is my alternate angle. So you can straightaway write down by AA, triangle BCF is similar to triangle EDF. And we're done. Okay? Okay. Then the next one we're going to look at is state another triangle that is similar. Okay, another triangle that is similar to these two here. So they must share the same angle, right? So let's color code it so you can see. This angle is clearly equals to this angle. And because of a parallelogram, 68 is equals to this one because opposite, right? So we have one that is the same. Then after that, where else is the same? We have this one here because of alternate angle. This is also the same. So just look at the angle color. See green, orange, blue, correct? This one is also blue, right? So it's also blue. So look at this big triangle. Green, orange, sorry. Oh my God, what happened? Green, orange, blue. So everything is the same, right? So you see from here, B is orange, C is green, F is blue. So it's orange, green, blue. So E, A, B. Can see that? So technically, don't need to prove, right? But you can also see that it's by AA, right? So follow the colors. It's part C, correct? Angle EAB. So there are so many similar triangles, so you got to be careful, okay? Okay, now we go on to the last part. Let's do this in the red color so it's a bit more obvious, all right? Okay, so what I have here, the ratio of AD to DE is 3 is to 2. Okay, let me just put that down. So 1, 2, 3. 1, 2, 3, 1, 2. This one also 1, 2, 3. Can see that? Okay, so what they want is the ratio of AB to CF. AB to CF from here. Okay, so what I need to see from here, oh, I realize there's one more similar triangle. You see this one and this one? Can you see that it looks like this? So what I have is I'm going to write this down here. Triangle EFD is similar to triangle EBA. Saw that, right? So that's why I recognize these two shapes, okay? These two shapes will save your life, trust me. So what you see from here is that this one here, the ratio is 2. If I do like corresponding, okay? ED to ED to EA. Let me write that down. I'm doing part I. ED to EA. What does this tell you? The ratio is 2 over 5, which means this is also 2 over 5. This is also 2 over 5. So when they want me to find AB to CF, okay, wait, so this one also 2 is to 5, right? So if this one also 2 is to 5, what happens here is that this is 5, right? So 5 minus 2 is, this is 3. So when they want AB, that's 5, and this is 3. Can you see that? So what we have here is our ratio of AB to CF is 5 is to 3. So this is using my similar triangles that I found from there. Okay? Okay, so now we do the next part. So the next part, I'll do it in another bright shade. Okay, so the next part is part 2, right? Okay, now they're telling you, right, that the area of this triangle is 9.72. Let me find, okay? EDF. Oh, okay. Let me just highlight this. EDF is 9.72. So they want you to find what? ABCFE. ABCF. Oh, the whole thing lah. Okay, so we're going to start with this one. This triangle and this triangle, they are what? Similar. So I'm going to write that down. Triangle DFE is similar to triangle. Follow this one, okay? DFE, CFB. All right, so since they are similar, what do you understand about their area ratio? You take their corresponding length ratio, you're going to square it. So this is 4 over 9. Okay, because here 2 is to 3, right? So square 4 over 9. So I got ratio of these two already. Then remember, this triangle and this triangle, they are also similar. So let me write that down. Triangle, what am I writing here? D what? DFE. DFE over, so now I'm using this one, yeah? DFE over triangle, wait, DFE over triangle. Yeah, why my line like that, I want to underline nicely, okay? Yeah, he cannot cooperate. Okay, I highlight. Okay, triangle DFE to triangle ABE. They are again similar, right? Then what's the length ratio? The length ratio is 2 is to 5. So 2 is to 5. So same thing, they are similar, right? So I got to square it. So when I square it, that's 4 over 25. So now what I want you to make sure is that, right, these two triangles are the same. Their units better be the same. So I'm going to put that inside first. So this one here is 4 units. This one here is 9 units. The whole thing was 25, right? So 25 minus 4, this is 21 units. So what they want is that they want the total, right? So you can see your total figure. Can I put here? No space, don't go down too small later. Total figure is 21, 4, and 9. Is that 34? Yeah, so that's 34. So since you know EDF is 4 units, so what we have is 4 units is 9.72 cm square. I'm sure you can go and find 34 units by finding 1 unit first. So divide by 4 times 34. So my answer will be 82.62 cm square. And my dear children, please take note, this is considered exact, so don't anyhow go and round up and down. Am I clear? Okay, so go and review your last concept here. Remember, whenever the triangles are similar, spot these two shapes first. Okay, spot your similar triangles. They have the right to not list out all the similar, so find them yourself. So similar triangle, how to get area ratio? You square the length ratio.